Welcome back to Wings and Bibles. I'm Dustin, and today we'll be covering 2-1-2 Visual Glideslope Indicators. Starting off here, we have Visual Approach Slope Indicator, or VASI. VASI installations may consist of either 2, 4, 6, 12, or 16 light units arranged in bars referred to as near, middle, and far bars. Most VASI installations consist of 2 bars, near and far, and may consist of 2, 4, or 12 light units. Some VASIs consist of 3 bars, near, middle, and far, which provide an additional visual glide path to accommodate high cockpit aircraft. This installation may consist of either 6 or 16 light units. VASI installations consisting of 2, 4, or 6 light units are located on one side of the runway, usually the left. Where the installation consists of 12 or 16 light units, the units are located on both sides of the runway. 2-bar VASI installations provide one visual glide path, which is normally set at 3 degrees. 3-bar VASI installations provide 2 visual glide paths. The lower glide path is provided by the near and middle bars and is normally set at 3 degrees, while the upper glide path, provided by the middle and far bars, is normally 1/4 degree higher. This higher glide path is intended for use only by high cockpit aircraft to provide a sufficient threshold crossing height. Although normal glide path angles are 3 degrees, angles at some locations may be as high as 4.5 degrees to give proper obstacle clearance. Pilots of high-performance aircraft are cautioned that use of VASI angles in excess of 3.5 degrees may cause an increase in runway length required for landing and rollout. The basic principle of the VASI is that of color differentiation between red and white. Each light unit projects a beam of light having a white segment in the upper part of the beam and red segment in the lower part of the beam. The light units are arranged so that the pilot using the VASI during an approach will see the combination of lights shown below. The VASI is a system of lights so arranged to provide visual descent guidance information during the approach to a runway. These lights are visible from 3 to 5 miles during the day and up to 20 miles or more at night. The visual glide path of the VASI provides safe obstruction clearance within plus or minus 10 degrees of the extended runway centerline and to 4 nautical miles from the runway threshold. Descent using the VASI should not be initiated until the aircraft is visually aligned with the runway. Lateral course guidance is provided by the runway or runway lights. In certain circumstances, the safe obstruction clearance area may be reduced by narrowing the beam with width of shortening the usable distance due to local limitations, or the VASI may be offset from the extended runway centerline. This will be noted in the chart supplement and/or applicable notices to air missions, NOTAMs. So these are a few examples of precision and non-precision configurations of extended runway lights. And then here's the diagrams of them and exactly what the lights are doing. Now this is a 2-bar VASI, so I'll just explain this real quick. So you got a far bar and a near bar, and usually they're off to the left of the runway. And the black means red and the white means white. So if you have 4 red lights, then you are below the glide path. You'll know you're on the glide path when you have the far bar is red and the near bars are white. And then you're above the glide path if you have all white. Now here's an example of a 3-bar VASI. So if kind of the same principle, if all your lights are red, then you are below both glide paths. And just a reminder that a 3-bar VASI can provide 2 glide paths. a lower and an upper glide path. So you'll know you're on the lower glide path if you have 4 red lights on the far and middle bars and 2 white lights on the near bar. You're on the upper glide path if you have 2 red lights on the far bar and 4 white lights on the middle and near bars. Above both glide paths, you will have 6 white lights. Now here's an example of different VASI variations. Just depends on how many lights they want to put on there. Precision Approach Path Indicator, or PAPI. The Precision Approach Path Indicator, PAPI, uses light units similar to the VASI, but are installed in a single row of either 2 or 4 light units. These lights are visible about 5 miles during the day and up to 20 miles at night. Now I know from experience it's pretty hard to spot a PAPI during the night at 20 miles, especially if it's in the middle of a big city where there's a bunch of lights around the runway. The visual glide path of the PAPI typically provides safe obstruction clearance within plus or minus 10 degrees of the extended runway centerline and to 3.4 nautical miles from the runway threshold. Descent using the PAPI should not be initiated until the aircraft is visually aligned with the runway. The row of light units is normally installed on the left side of the runway, and the glide path indications are as depicted. Lateral course guidance is provided by the runway or runway lights. In certain circumstances, the safe obstruction clearance area may be reduced by narrowing the beam width or shortening the usable distance due to local limitations, or the PAPI may be offset from the extended runway centerline. This will be noted in the chart supplement and or applicable NOTAMs. So here's an example of a PAPI. So you have 4 white lights, you're high. If you have 3 white lights and 1 red, you're slightly high. If you have 2 white and 2 red, you're on the glide path. If you have 1 white and 3 red, you're slightly low. And if you have 4 red, you're low. Next we have tricolor systems. Tricolor visual approach slope indicators normally consist of a single light unit projecting a 3-color visual approach path into the final approach area of the runway, upon which the indicator is installed. The below glide path indication is red, the above glide path indication is amber, and the on glide path indication is green. These types of indicators have a useful range of approximately 1/2 to 1 mile during the day and up to 5 miles at night, depending upon the visibility conditions. So here's an example of that tricolor approach slope indicator. So if you're below the path, it'll be red. If you're just slightly below the glide path, it'll be amber. Once you're on the glide path, it will be green, and above the glide path, it's also amber. And that's what it looks like on the side of the runway. So now we have what's called a pulsating visual approach slope indicator. So below the glide path, the light will pulsate red. If you're slightly below the glide path, it'll be a steady red. If you're on the glide path, it will either be steady white or alternating red and white. If you're above the glide path, it'll be pulsating white. So here's an example of alignment of elements. All right. Pulsating systems. Pulsating visual approach slope indicators normally consist of a single light unit projecting a 2-color visual approach path into the final approach area of the runway, upon which the indicator is installed. The on glide path indication may be a steady white light or alternating red and white light. The slightly below glide path indication is a steady red light. If the aircraft descends further below the glide path, the red light starts to pulsate. The above glide path indication is a pulsating white light. The pulsating rate increases as the aircraft gets further above or below the desired glide path. The useful range of the system is about 4 miles during the day and up to 10 miles at night. Alignment of element systems. Alignment of element systems are installed on some small general aviation airports and are a low-cost system consisting of painted plywood panels, normally black and white or fluorescent orange. Some of these systems are lighted for night use. The useful range of these systems is approximately 3/4 mile. To use the system, the pilot positions the aircraft so the elements are in alignment. The glide path indications are shown in figure 2-1-8. So we'll go back to this. So basically, from what they said, sometimes they're just a piece of plywood on a stick in the ground. And what you do is you position your aircraft so that it appears that they are aligned. So if you're above the glide path, the middle bar will be past these two bars. If you're on the glide path, it will look like they're in a straight line. If you're below the glide path, then those boards will look like this. You have one further, the middle one is closer to you, and then the right one is further away. And that's going to do it for this video on 2-1-2 Visual Glideslope Indicators. I hope you enjoyed the video. I'll see you in the next one. See ya!